Share screen. Fine. Is the screen visible to all? Please let me know. Hello. Is the screen visible?
Yes, sir, visible.
ठीक है, ठीक. Okay. Fine. So we had discussed in this lecture, in the previous lecture, about the steel structures and what are they, how they are formed, and what are the different shapes or different cross sections which are available in order to build or construct different structural steel or steel structures rather. We also saw the advantages and disadvantages of the structural steel. Those are used throughout the construction. And in the practical slot, I had also discussed about the physical properties, the design philosophies like the working stress method and the limit state design method. So just I will browse it. Working stress method, as you all know, it depends only on the elastic behavior of the material. It has very few advantages, but lots of limitations or disadvantages like it neglects the geometric material nonlinearity, buckling phenomenon, long-term creep and shrinkage, residual stresses, etc. So we have also discussed about residual stresses. If you remember, it is nothing but the remaining stresses which may be useful or most of the time they are harmful for the overall capacity of the material or the structure or the element component, whatever you can say. So all these limitations are there. On the top of that, you don't have a realistic measure to calculate the actual factor of safety. I mean, it is completely depending on some experimental results. Based on the experimental results on various samples, these factor of safety they are defined, which is not realistic. So, based on some earlier limitations, the design basis or the design objective is formed. So these are the following design objectives. In order to achieve these objectives, mostly the objective is to uh, structure should perform satisfactorily for the purpose for which it has been constructed throughout its design life. So I will be discussing about the design life in the further lectures. I will certainly discuss about this design life concept. Right now, just try to understand these few terms. Then, with an appropriate FOS, that is factor of safety, structure should sustain all the loads, deformations during construction, and have an adequate resistance to certain expected loads and fire. So, while discussing this point, I had also discussed about some expected loads. We took an example of Nagpur area. In the recent past, or let's say 20 years or so, there were no earthquake events. But certainly before 20 years, there were few earthquakes which have occurred in Nagpur and the adjoining areas. So we cannot just neglect all these forces which may come, which may arrive in the near future. So we need to take care of all these forces along with the factor of safety, right? Lastly, the structure should be stable and have alternate load paths to disproportionate overall collapse. The term of ductility which I had explained to all. This is an alternate load path. That means we should have some property of the material so that it can sustain the load, excessive load, without undergoing, uh, failure at early stage. It will deform, it will undergo inelastic behavior, but it will not collapse. So that is an alternative path. Based on this objective, limit state design method is framed. Limit state design method is also having the plastic design method concept, and it is just an extension of plastic design method. There are few disadvantages of plastic method. Those are covered over here. So limit state design, as you all know, it has got two limit states. One is strength and another one is serviceability. We have discussed this. You have also covered this part in RCC. Same things are repeated over here. Now, the essential components which a structure will carry throughout its life, those are nothing but the loads. The loads may be in the form of dead load, live load, or sometimes they are also known as imposed loads. Then the snow load, wind load, earthquake load, erection load, accidental loads like blast, impact, vehicle, etc. There may be few another loads such as the secondary effect due to contraction or expansion due to temperature changes, differential settlements of the structure as a whole or component. So these are secondary forces, those may come into picture. However, we should take care of these forces. These are essential ones. And for every load or every force, you will find there is one IS code, and there are different parts associated to this IS code. This is known as Indian Standard Code 1875, IS 875. There are four parts: part 1, part 2, part 3, part 4, and there is one more part which is part 5, which comprise of combination of loads. So it speaks about the combinations, various combinations which you need to consider while analyzing any structure. Remember, we cannot rely just upon only one load. That is, it cannot be simply the dead load. It cannot be simply imposed load or any other loads which are acting independently. There may be a case that the combination of loads will form some critical loading or maximum load, and because of the maximum load you will find the output result, that is in the form of bending moment, shear force. Those may also become critical or maximum. Okay, so that critical value we need to find out. That is what is analysis all about. Which type of loading, which type of combination will give me critical load, that we need to assess. Okay, so that is what is engineering all about: identifying the critical load, and then according to this load, then we are supposed to design the components. So in the practical slot, we few people were there and they had discussed. Uh, they told me that design is nothing but the decision of dimensions and the quantity of various parameters those are involved in defining that member or structure. Let's say, for example, RCC beam. I'm just taking one example of RCC beam. So in design, ultimately what you calculate the cross section, that is the width and the depth of the concrete, and you also calculate the amount of steel or reinforcement which needs to be provided for that given loading condition, isn't it? Loading condition as well as the end condition. Like if it is simply supported, if it is fixed, then the placement of the reinforcement and all, it will vary depending on the bending moment and shear force values, right? So this is what is designing all about. But before designing, we need to analyze. That is, identify the maximum critical value of bending moment and shear force. These two things initially are very, very important. So, is this understood? This is related to the loads. All are expected to study these IS codes, IS 875, part 1, 2, and 3. We need not to go into details of snow load as such. This is a very typical loading condition found in typical areas, okay, where snow covering is always there. So we need not to consider right now. Even if we concentrate on these three parts, it is more than sufficient. Later on, you can utilize your knowledge, whatever knowledge you have gained from these IS codes, then you can extend your knowledge to this no load concept also. Okay? There is separate code for earthquake load, which is IS 1893. The latest version is 2016. Okay. Now see, in working stress method, you have witnessed only one factor of safety. Just correct me if I'm wrong. And what is that factor of safety? The factor of safety is nothing but equal to yield stress divided by the permissible stress. Isn't it? Am I right? In working stress design, you have used the concept of factor of safety as yield stress divided by the permissible, allowable permissible stress. However, in limit state design, what has been done? The factor of safeties are applied for both the things. That is, one is for load, another one is for material. Okay? Why this has been done? Let us try to explore. These factor of safeties, they being distributed in two parts. That is, one applied for the loads and another one applied for the material. Hence, they are known as partial safety factors. They are nothing but the factor of safeties. But since they are applied for both material and the load, देखो क्या होता है कि कोई भी स्ट्रक्चर है, रेसिडेंशियल बिल्डिंग मान के चलो. In case of residential building, what do you observe? The members like beams and columns, they are made up of one material, let's say RCC for example, or concrete. And these materials, they are subjected to what? Loads like dead load, wind load, earthquake load, live load. Okay? So these are the major components whenever we speak in terms of any structure. Got it? So therefore, the factor of safeties which are associated to these major components, if they are applied simultaneously, then they are known as partial safety factors. And that concept has been introduced in your limit set design. This was not true for the working stress design method. So just try to understand these factor of safeties which are applied for loads. These are known as partial safety factors for loads. Why it has been applied? Just to account for uncertainties in estimating the magnitudes of dead or live loads. What do you understand by this statement? I will read it one more time. To account for uncertainties in estimating the magnitudes of dead or live loads. क्या समझा ये स्टेटमेंट से आप लोगों को? You can try. You can try. We will discuss it. There is no problem. Please try.
While construction of any building, the dead load can be different than the theoretical.
Exactly.
Due to some losses.
Exactly. Very correct. Excellent answer. So these types of uncertainties may be found in dead load as well as in live load also, isn't it? So the example which I had quoted, that in practical slot, let's say for example, a structure is meant for only 50 people, but 51st person may be there, or the amount of load, it may get exceeded because of some reason or the other. So such kind of uncertainty should be taken into account in the form of some factor of safety, which we call it as partial safety factor. Because partial, why? Because we are applying the factor of safeties to the loads as well as for the materials. Okay? So I hope you have understood this thing. For this, you will find in your IS 800 2007 on page number 29, table number 4 is given, and very frequently you are supposed to make use of this table. You will come to know. Now see, what is given in this combination. देखो, the thing which I had told you, that the loads cannot be applied independently, or they cannot be considered as an independent entity. They are to be considered in the form of some combination, and these combinations may be critical. So what are the combinations which are given as per the Indian Standard Code? Dead load plus live load and plus crane load. These crane loads are actually uh, used whenever there are multi-storied type of structures wherein you are supposed to make use of the crane for some erection process. So these cranes, they may be mounted at various different levels, and by the virtue of this crane load you will find some amount of dead load and live load is increased or it is added, right? So this is one of the combinations. Second combination is dead load, live load, crane load plus wind load or earthquake load. Wind load or earthquake load, and नहीं है और है. So it is assumed, it is considered in your IS code that the combination should not be taken simultaneously when wind load and earthquake loads are considered. Combination should be only dead load plus live load plus wind load, or dead load plus live load plus earthquake load. Either of this will give maximum combination, and it is uh, observed that when earthquake arrives, wind load is not predominant. It is observed. And when there is no earthquake and there is only wind, so wind load is predominant. And therefore, either of the combinations is to be considered. Dead load plus live load plus wind load, and dead load plus live load plus earthquake load. One more thing to be remembered, these earthquake loads and wind loads, they will not act only in one direction. There may be a possibility that in the other direction also this wind load may be acting. अभी देखो dead load या live load, they are vertical in nature. Don't you feel so? Live load, which is coming on the floor, it is with the help of some people which are who are moving on the slab. So it is vertical in direction. However, these earthquake loads or wind loads, they are actually acting in the lateral direction or horizontal direction. So that horizontal direction may be in the positive x or it may be in the negative x direction. Are you getting me? So therefore, the combination of dead load, live load and wind load, it has two more combinations like dead load plus live load plus wind load, and dead load plus live load minus wind load in x direction. Similarly, dead load plus live load plus earthquake load in x direction, dead load plus live load minus earthquake load in x direction. Are you getting me? Please let me know. Have you understood this
Yes,
thing?
sir.
Okay. Similarly, dead load plus minus wind load or earthquake load, and dead load plus this erection load, dead load plus live load plus accidental load. So accidental load and these things, these two stuffs, they are not used frequently, in the sense they are very specific, condition based. Therefore, they are we will not make use of these things. We can see the usage of first three combinations. Okay, and over here you can see for limit state of strength and limit state of serviceability, there are various factor of safeties which have been defined, derived with the help of probabilistic approach. तो इसमें बहुत सारे रिसर्च होता है. Probabilistic approach यानी mathematics is involved, and in order to calculate probabilistic probability, we need to have some data. Some data नहीं, maximum data, बहुत सारा data चाहिए. ठीक है. So just try to understand. I will not go into the depth of this. Try to understand that for various loadings, numerous experimentation work is carried out for different combinations, and mathematics is used in order to calculate these factors, whatever are represented in this IS code. ठीक है. So these are the different types of magnitudes you will come across for the limit set of strength whenever we are using these combinations. And in this also you will come to know that the second column, this is of our use. These leading and accompanying live load concept, this is not used for our study purpose. These are again for specific use, which you are not, which I think you should not get introduced right now. Similarly, for limit state of serviceability, these are the magnitudes or values which are expressed. So you can see for dead load only, we will be making use of these values. Okay. So limit state of serviceability, in the sense you are supposed to check the deflection criteria, shear criteria. Okay. So this is about the partial safety factors which you will be using for different loading combination. Got it? Understood?
Yes, sir.
Okay, fine. Similarly, we are supposed to follow the partial safety factor for material. And what is the reason? I will read it out. To account for the uncertainties in the structural steel developed during manufacturing process, construction, local buckling, ये बहुत important term है, local buckling. I will let you know, etc. So this statement I suppose is clear to all. देखो क्या होता है, देखो we are using the hot rolled section. Hot rolled section I have already covered that how it is manufactured, how hot rolled sections are developed, and keeping in view their limitations of such kind of hot rolled sections, wherein you will find there may be distortion, there may be some kind of residual stresses, those may be there, isn't it? So those manufacturing defects need to be considered while designing. One thing. Secondly, when these hot rolled sections are brought into construction work, there may be some kind of human error. क्या होता है, कोई भी section, prefabricated section, if it is brought onto the construction site, there are maximum chances that the prefabricated material or the member, it is manhandled. In the sense, if it is placed, if it is carried from one location to another, then there are chances that the laborer or the machine by which it is transported from one location to another, it may, leave it as it is, and from a certain height it may fall, and because of that fall there are 100% chances of some kind of damage associated to that member. So such kind of construction uncertainties may take place for those materials. And the last term of local buckling that I will be explaining you. So such kind of partial safety of materials, they are mentioned on page number 30, table 5 of your IS 800-2007. So you can see the description: resistance governed by yielding, buckling, ultimate stress. Since you will be making use of bolts and welds, so for bolts Different types of bolts are available, like friction type, bearing type, rivets, welds, etc. These are the factor of safeties which are available. We will be making use of all this while solving the numerical. Okay, so we will see to it what are the different partial safety factors those can be used. So have you understood this thing? Okay, partial safety factors.
Yes, sir.
Fine. Then the main, what you can say, formula or the concept, that formula or the concept of limit state design method is summarized with the help of this formulation. What it says: design action or design loads should be less than or equal to design capacity or design strength. This is what is expected in our limit state design method. And while defining this, what it is expected, that if we talk in terms of loads, then it should accompany with the factor of safety, as well as if we are talking in terms of strength, that is nothing but the material or the capacity of the material or the strength of the material. Over here also we are supposed to take care of the partial safety factor. So very intelligent way, in a very intelligent way, what the IS code has done, when it speaks about the loads, in that case the partial safety factor is multiplied to the loads. That is, we may be anticipating increase in the load in the future, whereas the design strength or the capacity of the material is slightly underestimated, so that whatever dimensions we calculate for the given material, those may be on the higher side, correct? And therefore this partial safety factor has been divided for the strength of the material, which is denoted by S suffix D. This is denoted by QD. So the formulation is gamma F. This is partial safety factor for loads, which is given in table number 4. It is multiplied by QCK. QCK is the characteristic load. Okay. Similarly, SD is then redefined as SU divided by gamma M. SU over here is the ultimate strength. Ultimate strength का मतलब this one. I will go back. This is your ultimate strength. Okay. And over here some partial safety factor has been introduced. इसका मतलब क्या है? Just try to recall the elastic behavior of the material. In working stress method, what you used to do, you used to calculate the material strength or design strength by dividing the yield strength by partial factor of safety, isn't it? And because of which the value which was actually over here, it reduced to somewhere here because of the introduction of partial safety factor for different material. So for concrete, how much partial safety factor do you make use of in working stress method? What is that value?
1.5.
1.5. And for steel, how much it is?
1.15.
1.15. So these these factor of safety is, don't you think the value is very less compared to the discussion what we have done right now, wherein the partial safety factor is introduced at this level. तो कम हो के कितना होगा? यहाँ तक होगा, isn't it? Even we make use of the partial safety factor value, which is given in this table for material. It is 1.1. Maximum is 1.5. Maximum is 1.5. Otherwise, you will see for yielding, buckling, ultimate stress even, it is 1.25. So even if we make use of such kind of partial safety factors, which is used for the ultimate strength, the overall value will not reduce. Meaning of this is, in limit state design method, we are trying to explore the maximum capacity of that material. Okay, okay. So this is how the limit state design method is all about, and this concept now we will be discussing at length. Okay, so you have understood the limit state design approach, and now we will be now introducing few more terms which are very essential for your understanding purpose and for this subject, for this course. Everything revolves around this explanation. Okay, so just try to understand this thing. See, your hot rolled sections or the structural steel which you are making use of, that is made up of mild steel. Typical behavior, stress strain behavior of mild steel is shown in this figure. Over here, what do you expect? Upper yield point, lower yield point, and this non-linear behavior, which is known as the strain hardening, and after that, necking starts. Necking in the sense the cross section of the material, it reduces, and there is a formation of cup and cone type of arrangement, which will eventually break or it will get fractured. In this process, you obtain some maximum strength, which we call it as the ultimate tensile strength, right? So now, since this is a complex curve, this is a non-linear curve, and we don't know what is the degree of this curve. We need not to know even, right? What is done in order to simplify things and in order to take into account this strength? What the scientists they have done, they have considered this zone, which we call it as the plastic zone. Why plastic zone? Because even if we remove the load which is applied to the specimen or the material, the strain or the elongation, it continues to be remain same without going back to its original shape. So that's why this is known as the plastic zone. So what is observed actually in plastic zone, the the this zone is very large. It is very large. Although it looks small over here, or the final this thing is very small, but the amount, the value of strain associated to this point over here and over here, if you compare this distance, it is almost 10 times, sorry, 100 times, sorry, 10 times this value. Okay, so therefore this is quite long, this distance is quite long, and therefore what scientists they have done, they have considered this plastic zone to be linear one, and they have extended it up to the fracture zone like this. Can you see this line, dotted line? Okay, so this being a long portion, this has been extended linearly. Okay, and they have considered this lower yield point to be the yield stress value. Okay, this is what is known as yield stress value. Earlier you must have studied the notation for yield stress to be sigma y. Now it has been it is represented by fy. This is the only difference. Okay, so while denoting or while saying yield stress, I will be saying it to be f suffix y or fy. Is this okay? And the associated strength will be epsilon y. Okay, so instead of sigma y, now it is fy. So This is the Fy value, and this Fy value is linearly extended up to this fracture owing to this length, since this length is quite long. And if we extend this, there is an advantage which I will be discussing in the further slide. So just try to understand, this has been extended linearly so that this non-linear curve is now eliminated. And what the scientists they believe, that whatever curve is formed with the help of this horizontal line as well as this inclined straight line, this is known as bilinear. Bi in the sense two. This is one linear line and this is another linear line. Bilinear elastoplastic stress strain curve, which is also known as idealized stress strain curve. Idealized in the sense it has been modified. This was the true stress strain curve. However, with some understanding, this has been modified and or it has been idealized in the form of bilinear elastoplastic stress strain curve. Why elastoplastic? Because up to this point, the behavior is elastic, whereas from this point onwards, it is completely plastic. Okay? So this has been idealized. This is one assumption which the scientists have made. This is the assumption which is to be remembered for our further discussion. So have you understood this idealization?
Yes.
Now, this idealization is considered to be same in compression as well as in the tension zone. Actually, this is a tension figure because we have applied tension force. It is assumed, because compression, steel is not that much strong in compression, isn't it? So even if we perform compression test, the stress strain curve, whatever is obtained, it is of similar nature. Similar nature. Okay? So again, the scientists, what they have done, they have considered the behavior of the stress strain curve, and in the tension, you can consider this to be the tension case and this to be compression. This to be same, okay, in this manner, right? So these are a few assumptions, and now this is now the important thing which we need to understand, and based on this you will find the complete IS code it revolves around. Okay? Now just try to understand. See, I have considered I section. Can you see this I cross section? And this is the beam, which is called as the I beam. And this I beam is supported over here like this. Simply support case. One roller, another one is hinged. Yeah, it is assumed to be simply supported one. What I will do is I will consider few things. I will assume few things. First assumption is I will assume that for this given beam, idealized elastoplastic stress strain curve is developed, or I will consider in order to study the overall behavior in the form of idealized elastoplastic stress strain curve. That means I will be applying this concept or this concept. Second assumption is beam is bent by pure couple, axial shear force, stresses other than normal stresses, they are neglected. So beam is supposed to be bent with the help of pure couple. You can see these are the couples. Okay, and the magnitude, initial magnitude is, let's say, capital M. Third assumption is plane section remains same before and after bending. And fourth is cross section is symmetrical with respect to axis of bending. All these are the assumptions. And with the help of these assumptions, let us try to now study what will be the effect of this couple, whatever I am using on this beam. Okay, these assumptions are done in order to uh, study the theoretical behavior of any beam. This is the theoretical behavior. With the help of this theoretical behavior, you will find that experimental results are also verified. तो मैं एक वीडियो दिखाऊंगा आप लोगों को. Based on that video, you will come to know that whatever theoretical concept we have studied right now, that is more or less same. But for that, we need to assume some things. So these are the few assumptions. ठीक है? Now, with the help of these assumptions, let me introduce the moment. So initially what I will do, I will apply very small moment whose magnitude is, let's say, small m. And by the virtue of this moment, what do I observe? That there are strains and associated stresses, those are developed. Okay, so you can see, can you see these red marks over here? Red lines.
Yes, sir.
These red lines are the representation of stresses which are developed by the virtue of initial moment. So initially, whatever moments are applied or whatever couple value is applied, by the virtue of that, initial stresses are developed. Okay? And these stresses are developed on this face. What is this known as? This or this? क्या कहते हैं इसको? This is known as flange, and this portion is known as web. Okay, so in the flanges you will observe that because of this moment stresses are developed. Okay, I have represented it with the help of this. Later on, I will increase the magnitude of this moment or force. Then what will happen? The stress concentration will again increase. Okay, and during this process, what will happen? See, let's say for example the first case, stresses are developed in the on the compression side, but you can see in the tension side also, because of that bending, some stresses will be developed, isn't it? Those stresses will be of same magnitude only because of this assumption. So what we have assumed, that whatever stresses are developed in the compression side in order to maintain equilibrium, because you can see in the compression side, in order to maintain equilibrium, same stresses will be developed in the tension side as well, only because of this assumption. Okay, so you can see, if in the compression side the stresses are in the red color, even in the tension side same stresses are developed, and because of that equilibrium is maintained. Then with the further increase in the moment value, these green stresses are developed in the compression phase, and in order to again maintain equilibrium, what you will find in the compression phase, in the tension phase also you will find similar stresses to be developed. Are you getting me? Okay.
Yes, sir.
And what you find simultaneously, if you plot the stress versus strain behavior, so you can see for the first condition or first moment value, the strain value is linear. Okay, Why? Because you can expect that only the flanges they are contributing in taking the load or stress. So you can expect that the behavior of this stress versus strain behavior for first condition, it is up to this. That means only linear behavior is expected. That is, Fy is obtained for condition number 1. With the further increase in the loading value, what do you expect? That now the stresses are, they have already consumed the flanges strength, and now they have slowly entered into web portion. Okay, somewhere here. That means the utility of that material or the capacity of the material is now getting explored after Fy value, after the yield stress value. And you will expect that for the second condition, some portion of the web will take the stress. And that stress value will be taken not only on the compression side, but also on the tension side as well. With the further increase in the moment value, what you will expect? These blue colored stresses in the compression as well as in the tension side. And what you find that at this point where these stresses on the compression as well as on the tension phase they meet, that means the complete material has been explored to its fullest capacity. At this point, can you see this black spot? At this very point, what happens? There is a development of hinge, and the property of this particular hinge is that even with the further increment of the load or the moment value, what will happen? There will be infinite rotation, because what will happen at this stage? The complete material will break with the further increment of the load or with the further increment of the moment. Okay, this is going to break. Or over here you can expect the formation of neck. So in other words, this is known as plastic hinge. Okay, plastic hinge. Why? Because see, uh, what the scientists have done, they have idealized this stress strain curve, and what they have termed this to be the plastic line or elastoplastic behavior. And therefore the hinge which is associated to this failure type, it is known as plastic hinge. Okay, so at this third stage, what do we expect? That these stresses on the compression as well as on the tension phase, this is going to develop one breaking point which is known as plastic hinge. And the axis associated to this axis is known as equal area axis. Why? Because uh, uh, it is expected that this particular axis will divide the upper portion, that is the compression phase, and the tension phase into two equal areas, and hence it is known as equal area axis. This equal area axis may not be same for all the cross sections with the neutral axis. There may be a change over here, since I have considered an I section whose dimensions are same. Therefore, in this case, the neutral axis and the equal area axis will be same. However, let's say if this was some T section, in that case, the neutral axis and the equal area axis will be different, right? So what is equal area axis? Equal area axis is nothing but it is that axis which will divide the member into two equal areas. Okay. So what do you observe over here? You can see the strain figure, it won't change. There will be only increment in the strain value. It is linear. However, over here, can you see the difference? What has happened? The stress behavior has changed. Okay, this stress behavior, if it was some non-linear behavior, because you can see in stage 2 or in loading 2, what has happened? The material has entered, or rather the stresses has entered into the web portion, or it has entered into the plastic zone. And because it has entered in the plastic zone, non-linearity can be expected. But since what we have done, we have idealized that stress strain curve and we have considered this to be straight line. Because of that, you can see this behavior is again a straight line. Are you getting me? This variation of the stress is straight line. Okay. And within the stage number 3, that is from here to here, again it is completely straight. And because of which the variation of the stress over here in the stage number 3, wherein complete moment has been used and complete stresses are developed, at that location you will find the variation of the stress to be again straight line. In the earlier stage, that is over here, you can see the variation is like inclined one, which is true in this case. Whereas for second stage, it has modified in this manner. So therefore, this straight line, this vertical line, this is nothing but the reoriented stress strain curve. Okay, if you reorient this stress strain curve, you will find this figure. Okay, so uh, on the compression phase as well as on the tension phase, we will achieve this situation only based on this assumption. And ultimately what you will be getting, the development of plastic hinge. So I hope to some extent you have understood this behavior of the curve. Okay, I hope it is understood. I will be explaining you or I will be showing you one video wherein you will find development of plastic hinge in experimental case also. Okay, I hope this is understood.
Yes, sir.
Okay, so I will stop over here. In the next lecture, we will see the further discussion. Thank you.
Sir, can you please share the slides of the PPT which was discussed in the
Practical slot now.
practical class?
Yes, yes.
Yes, sir.
I will be giving you this complete PPT once I complete the discussion. Hai na?
Sir, and recordings?
Recording also, everything.
Yes. Okay, sir.
So I have already posted one recording in the classroom.
Yes, sir.
ठीक.
First lecture.
Yes, yes. ठीक है?
Yes, yes.
Okay.